In this video, we're going to be testing the claim about a proportion, and we're going to be using the critical region method. This is the formula for the test statistic, but I'm going to be using a calculator, so if you want to do it by hand, this is the formula you would use, and this is what each part of the formula means. So for this example, the company Drug Test Success provides a one-panel THC test for marijuana usage. Among 300 tested subjects, results from 27 subjects were wrong. Using a 0.05 significance level to test the claim that less than 10% of the test results are wrong, does the test appear to be good for most purposes? So we can see that we have a 0.05 significance level, and we are testing the claim that less than 10% of test results are wrong. So let's start off with writing out our hypothesis test. So our null is going to be P equals 10%, so 0.10, and the alternative is going to be P, and it says less than 10%, so we're going to say less than 0.10. And we also have a significance level, or an alpha value, of 0.05. So we got to find the critical value from this. So we can go into our test chart for our z-chart for this, and we can look for the closest to 0.05, which is going to be in between these two values since they're the closest, right here. So negative 1.6, and it's going to be in the middle between these two, so 0.045. So negative 1.645 will be our critical value. So critical value is going to be z equals negative 1.645. Because it's a left-tailed test, we make sure that our critical value is negative. You can also have done this in a calculator. If you wanted to, you would just go to second and vars, and we're going to do inverse norm. And we would just say 0.05 for the area, leave everything else alone, just hit enter. And we would also get negative 1.64 and round it up to a 5. So whether it is the calculator or the chart, both will work just fine. Now, we need to set up or pick out what we do know. We do know that we're testing the claim that test results are wrong, and we saw that we have 27 subjects that had wrong test results. So we have an X value of 27. We also know that we have from the question here that 300 people were tested. So our N value is 300. Now that we have everything we probably need for now, I'm going to go and bring up the calculator again, and we're going to jump into one prop z-test, because this is a one proportion z-test. So stat test and number 5, one prop z-test. So we need to know our p naught value, our p0 value, which comes from the hypothesis test, so 0.1. So p naught is going to equal to 0.10. So that's what we're going to type in here. So 0.10, x is going to be 27, n is going to be 300, and one more 0. And then our alternative hypothesis was less than, so we make sure we select less than. And then we go down to calculate. And that's going to give us a t-stat of negative 0.577 and a p-value of 0.2818, but we're only concerned with the t-stat, but I'll write both in anyway. So t-stat, since it's a left-tail test, is negative 577. And our p-value is 0.2819. 0.2819. But like I said, we're more concerned with the test statistic, not the p-value. But there it is if you are curious. So now we're going to look at our distribution and see where our critical value and test statistic line up. So 0 in the middle, and negative 1.645 is going to be somewhere, say right here. 1.645, and since it's a left-tailed test, we shade to the left. Now where is our test statistic? Where is negative 0.577? Well, that's going to be somewhere over this area. So say this is somewhere here to the right side of negative 1.645. So this is not in the rejection region. Since it is not, we fail to reject. So we know we failed to reject. Now we need to actually write out our answer as a sentence. Zoom out a little bit, give some more space. So since we failed to reject, we do not have enough evidence. So we can say that there is not enough evidence to support the claim that less than 10% of test results are wrong. Since the claim that is less than 10% of test results is wrong, but since we failed to reject, we can't support that. There's not enough evidence to support that. Now the other part is, does the test appear to be good for most purposes? Well, 27 people out of 300 got bad test results. That'd be bad for a job or anything else where you need to make sure that you are good to go. So I would say that the sample results suggest the test is wrong too often to be considered reliable. Even though it's 27 out of 300, that's just a little bit too much for my liking.